hear me well? If not, let me know. If yes, let me know as well. Yes, thank you, Brenda. Okay, so I basically will start sharing right there. Share. Okay, so I'm sharing my screen, and today we just will go through the last topic. Actually, throughout the semester, we have covered quite a bit of land in Java technologies, and we started from the basics and went through until the topic number 9, which is functional programming. We looked already a week ago into the lambdas, so now is the last topic which I have to present you guys, which is streams. So basically today I will go through the slide set, show you a couple of examples, and that will be it for the semester. So basically along with that, you guys can still submit your tasks if you haven't done so yet, and I have to fix these anyways. I think own you a few fixes, most of them coming from task 2, some of them are coming from task 3 as well. So I will do that in a week, and even though we don't have any topics anymore to cover in a week, but I suggest we do meet. So we will talk about the exam. So I will give you an update with respect to the form of the exam. We'll most probably give you a few example questions, and we will set up the date. So so it would fit us the best. So again, a reminder, if you want to be allowed for the exam, you have to submit the task number 1. And until the end of this month, so basically we have something like 10 days, you still can receive points coming from the task 2 and task 3. So nothing yet lost, and you still can gain. For the task 1, it is not possible to get points, but basically you can get an allowance for the exam. Okay, so other question, if any questions, I will ask you after the topic is laid down. So please hold on for the lecture. Okay, I'm starting my presentation. Okay, so this is a slide set you have already possibility to open in your computers. So this is another improvement in Java that started since Java 8. It is a possibility to iterate throughout the collection of elements by constructing a pipeline. So this technology in Java is called streams. So basically I will run through these possibilities about the streams, explain a little bit about the functionality and the benefits out of it. So this is actually quite well related with lambdas, because this all gives a possibility to run a stream. So basically iterate over the collections on the parallel computing environments. So basically you can split execution of the streams onto multiple cores or CPUs. And this is very handy, because in most of the cases when working in the systems, in the object-oriented or whatever other systems, what we do, we iterate elements over the collections. Okay, so let's start with the stream. So basically stream in Java is just a collection of elements like any other collection. But the difference is that basically the stream is not persistent. It doesn't have any state in itself, and it doesn't have data. So this is just basically like a pipeline. You construct a pipeline, right? So you basically put up a bunch of aggregate operations that work on the elements of the aggregation, and then basically you click and execute. So this is an example. For instance, you just basically have the collections dot stream, right? So you start with stream and then you put up operations that do something on the elements of the stream. And that's it. So basically it gets kicked and executed once you just basically construct it and let it go. Okay, so pipeline elements can be of a few flavors. So you can have a source. This could be a collection, array, whatever. So basically, whatever is capable of generating an element, right, or taking it from some kind of a collection or I/O channel, etc. So it basically is considered as being a source for the collection. So just like a source for any stream in nature, right? Water source. It's a point where water starts from. Okay, so elements are coming from the source. Then there are intermediate operations. So basically, intermediate operations act as a individual pipe in the pipeline. And these operations are basically split into two types, stateless and stateful. One of them does not retain any state and just doesn't care about the sequence of elements and whatsoever. And the other one just has some information about what had happened already. So it stores the state, it can use that state for any purpose with respect to each of the element, etc. So there are two types of intermediate operations. And operations can be terminal ones. So basically we terminate the stream. Whatever we do, they just do not return a stream, right? So other operations that are intermediate or source, they basically return a stream. That's why you can put the elements into the pipeline. And the terminal one just does not return any stream. It can return a literate value, like a primitive or an object or whatever, or a collection, or just can return void, so basically nothing. Okay, short circuiting operations are basically the ones that are given on the infinite stream. So basically we can have a producer which generates an infinite random values, for instance. And the shortcutting operation is such that on the infinite stream, infinite input, it basically produces a finite stream as a result. And short-circuiting operation can be as well a terminal operation. Given an infinite input, it basically terminates in infinite time. So basically, it just shuts down the infinite stream. And this is very handy and useful in the case when you, for instance, generate something in the infinite loop, or for instance, work in the environment which generates some data like an IoT device and generating something constantly. So you want just to terminate at a given time. Okay, so there are lists. This is the slide which lists basically various features or so-called advantages of the streams. So basically, again, since we don't have a stateful overall of the pipeline, so we can tell that stream do not have a storage. It doesn't store anything, right? So it basically works on a stream and returns something which is to be calculated on the terminal operation or anywhere else. Okay, so functional in nature. This means that streams are constructed and designed so that streams can be split into the multiple cores. So basically, multi-threaded is in the nature, and that's very important because we can parallelize a stream. By constructing a stream, if we would not use anything from the outside, which is possible, as you know, in Lambdas, we can basically make sure that our stream can be parallelized later on. Okay, lazy evaluation. So basically, we can construct our stream. We can take it by the variable or a handle, and then we just can attach to the source, and it starts kicking in, starts working. Until it is basically executing or attached to the source, it does not do anything. Okay, automatic parallelization, which I told about. Infinite streams, yeah, so you can have some kind of a generator which is infinite. Of course, the infinite streams are not that much useful because it is an infinite stream, right? But you can limit by the short-circuiting operations these streams, like find first, limit, and so on. Okay, and consumables means that elements on a stream are visited once during the life of the stream. Okay, so basically once the element is being consumed, that's it. The element is basically no longer put again in there. Okay, so this is a slide that basically shows various ways of kicking up the stream. Right, so we have a possibility basically to put in individual values from an array, taking them from the array, from the specifically array. This is the array which does not have a handle. These are the normal arrays. From a collection, it's very handy, dot stream, and it starts the stream. From a function, generate and iterate, right? So builders, etc., etc. So various ways. And of course, you can kick up the stream from the previous stream. So once you have a stream as a, for instance, variable, like here, you can put the distinct, filter, limit, etc., etc. These functions we will look at later on. But what these guys, an intermediate so-called functions return, these functions return a stream by themselves. Accepting a stream, right, and returning a stream. Okay, so this is for each. I will go through various most commonly used operations, which you most probably will be using in a task number 3, because task number 3 in the persistence, the final, the second part, I would say, the second part of this task actually has some operations that need to be created by you. So basically, you can use this as a reference. So operations for each, it does something, it consumes, right? It consumes. So basically, this is a lambda. Remember, this is a functional interface, generic one, which accepts some kind of a value and returns nothing. That's why this is a terminal. For each, this is a terminal operation that consumes elements, right? So basically, as an example, we have a stream of some elements coming from array, and for each, what we do, we print out here, right? We just put up a lambda which consumes these elements, and stream of employees, and for each of them we increase the salary, right? We just, for each employee in the list, we basically get set salary, we get the salary and multiply by 10%, so basically increase of his salary, and so on. So various manipulations, and basically this function returns void, so nothing is returned after all. Okay, so peak, this is an intermediate operation that what it does, it just executes a consumer like before, but it returns a stream, right? So on the stream, you can put a peak and do something with the value, or you can print out what's going on in the stream. So for instance, we have a stream, we have a filter event, and when we peak, we'll look up the value. So what it does, basically prints out what element actually passes through the stream. Okay, then filter. This is obviously an intermediate operation which is on to the stream, and it accepts a predicate. Predicate, just a reminder for you, it is a function which returns an argument, which receives an argument t here, right, and returns a Boolean. So basically, on a stream of numbers, you can filter, so the number actually modulus of 2 equals to 0. So this is a filter. So only a certain elements that are returned true by the predicate actually passed through for the filter in the sequence. These are the two filters. So at first filtering by one condition and then by the other, and so on. So I think this is clear. Once we started our stream, basically we can put up various filters. So it is being filtered. All these elements are being filtered, and only the ones that the condition matches actually passes through. Okay, so map is another intermediate operation which basically maps from one kind of stream into the another kind of stream, right? What it does, it has a function, so-called a mapper here, which receives an element from the stream and returns another kind of element to the later stream. What it does, so this is a lambda, this is a function which converts a stream to the different type, right? So basically it receives T-type element and outputs R-type element stream. Okay, so these are various possibilities to map into the primitive special case functions, right? So here, for instance, okay, this is not that much conversion, but we have a stream of strings and then filtering, then printing it out, and here just mapping to the other kind of string. So this is not actually mapping, this is modifying. But in some cases, this is a mapping because, as you remember, string is an immutable operation. So this is not a modification, this is actually mapping. But it doesn't change the type of the stream elements. Okay, so map is quite useful because it takes and does the conversion of the stream element type. Okay, so this is a map again and an example. So for instance, we have a stream of IDs of numbers, right? So it's being put in, boxed. What it does, it converts from the primitives, integers, into the objects. And then it maps from the integer into the persons, right? So after this, only person stream is going on. So what it does, it basically looks up for the right person by ID, right? And injects first, which matches, or else, meaning or null. And then we have a filter, which basically filters out nulls. Then we check that filtering that the person country is actually equals to LT. Then we map again to the city of the person when we get distinct cities, right? And then for each we just print it out. So basically in the beginning, having the list of IDs of persons, we want to get a list of cities in Lithuania, distinct list, right? Distinct list of these guys from Lithuanian cities. Okay, so this is basically filtering looping operation set. And you can imagine if this stream is very large, what we can do with one click, we can basically parallelize it and make it work much faster than it usually would be doing before the streams. Okay, so find first. These are short-circuiting terminal operations like find first, find any, and optional. Optional we talked about. This is just a class which always returns not null object. You can check for presence of the actual value or a null, right? So that's why find first and find any returns these optionals. So basically, for these guys, we have to inject the not null element, right? So basically, now we have a stream of ages. This is boxed, right? Then mapping person by age, filtering, and find any or else return null, right? So basically, find the first person and find first here, find any here. So it basically returns the first element which was found on the stream, right? Okay. So basically, yeah. So basically, this is just return of the first element, whatever, which is being reduced. Okay, operation reduce. Operation reduce. So this is reduction terminal operation. which basically takes an identity. This is the first element, right, of type T. This is the initial thing of type T, which is about to be returned. And this is operation that accumulates other values and returns T all the way. So how it actually reduce works. So for instance, starting, you have a stream of names, and then you reduce that in a way that you can concatenate all these names. So you start from empty string, right? This is your initial value. And what you then do, you just concatenate the string to that one. You basically go and concatenate, and this return concatenates all the values, right? And this one just returns a maximum value. So what it does, it basically starts from the minimum, right? And then it compares it to whatever value is in the stream, and it returns maximum. So at the end, this is the maximum. Right. So for instance, reduce can be used for summing all the elements in the stream. So we have a stream of integers, and in reduction, what we do, we have starting from 0 because we want sum, right? And then we have A and B, 2 arguments coming into the lambda. And then we have A and B and A plus B as a result. And this basically is being applied to all the elements. So at the end, we get sum. Right, so this is all the different options for how you can write this summing operation, basically, by using reduce, or just basically shortcut by sum. Okay, so basically MapReduce is a classical combination for working with the large big data storages. So basically you can map from one type into the other, do some additional filtering, then do again mapping, right? So basically mapping whatever way you want, and at the end you just basically reduce. You calculate some kind of a metric like sum and so on. Limiting, short-circuiting operations. So for instance, you have whatever length of a stream, and you want just take some number of them to pass it through. So this is the size that you basically define. Skip, the number of elements you just want to skip, right? So this is an example. You want to limit 8, and then you skip 2. So you start from the 3rd and until the 8th. Okay, so all these are understandable functions. I think there's no need to explain more clear. So basically sorted, once you have a stream, after this operation, you basically have a sorted stream, but you need to take care about comparables, right? About the comparables and so on. Sorted with comparator, if you have if your elements are not comparable, or you want to apply some special comparing operation, so basically you can inject the comparator of your own. Okay, the minimum value, so basically this is a terminal operation. It returns the minimum from the stream. The maximum value, it returns the maximum from the stream. All these are terminal operations. So this, again, we have an IDs of people for the persons when we do some find, etc. And then we just basically sort by salaries. And then we take 10 topmost salaries and we return them, and we just basically print. This is very handy like this to write. Okay, so this is the stateful intermediate operation. So basically, if we want a stream of distinct elements, so basically it remembers the state, does not allow to pass with duplicate elements by looking into the equals method. Right, so basically the stream of any IDs 1, 2, 3, 1, 2, after the distinct is just 1, 2, 3, and 1, 2 would be skipped, right? And you can put into array, so easily filtering. All match, this is the predicate on a stream that basically examines the predicate which is provided as lambda for each element, and it returns true if all elements in the stream have matched this predicate individually, right? Non-match, so this is vice versa. Any match if there were any element in the stream that actually matched the given predicate count, right? So this is basically counting. So if you want, for instance, to write it differently, the number of elements in the stream, so you can basically map to long, right? So each element is mapped to 1, right? So it basically a stream of ones, and you basically what you do, you just sum them up, right? Okay. Parallel, this is a very handy method that you can parallelize a stream. Intermediate operations. So once you kick up the stream, you have a stream floating, you can tell that do with this parallel stream, and then all the other stream is basically parallelized and go into the multiple threads. Number of threads are actually estimated by looking into what's available for your machine. Yeah, so right from the list, you can kick on the parallel stream. This is exactly the same like it was done before. In the example before. Okay, so on the flight infinite streams, these are the streams that basically generate something. So in order to generate, you need to provide a supplier, which accepts nothing and returns the type T, right? Object. So basically these objects are being generated. So you need to take care that it is being generated, right? Obviously, that these methods that generate infinite streams need to be terminated. Otherwise, you will get the error exception because they need to terminate at some point. So compiler basically takes care of that. Okay. Iterate. So you start from something and then you iterate basically. Yeah, you just execute like this, right? Embedded composite functions. Start from something and then you iterate over. So for instance, here, generate random person, then we shortcut it basically by limiting to 20 and we collect them. So 20 random persons generated to the list. Iterating, starting from 1, basically 1 times 2, and then 2 times 2, and then so on and so forth. So basically this is iteration. Streams are great, and this is what you start with, iteration process, and then you just add an exclamation mark. So you will end up streams are great with 1 exclamation mark and so on and so forth until the 10th, right? So this is the iteration. Okay, to slightly more complicated operations. So basically, collector performs an operation on elements that collects basically these elements into into some kind of a collection, into some kind of an object, and this is a terminal operation. Right, so you can write your own version on how you actually want these elements to be collected. I think we had this example in Lambdas already, where we basically had the filtering and collection of elements simplified into some statistical metric. So basically, for instance, having a string of streams and we want to collect, we start with the new array list. When for each element we call array list add, right? And then we call on the array lists, we call add all, right? So basically adding array list to the array list. And this ends up with all the elements put it into the list, right? So this is the concatenation. What we do, we start with the string builder, new. So we have a new string builder object in the beginning. Then for each element, we have a string builder append. We append elements. And for the string builders, we append another string builders. And this ends up with the concatenated string. Yeah, so like this. And in Java, there are some special collectors that, for instance, allow grouping. So we can easily group, for instance, since we have a person stream, we can have a map of persons grouped by the city, for instance. These are the grouping options, right? So from the stream of persons, just persons, right, we can create a map where we have a value here and the list of persons by some condition. So here by the cities. And here is a little bit more complicated. So we have embedded groupings. So for instance, we have grouped by state and then by city. So out of individual person stream, we have state, map of states, and the map of cities. And persons are actually grouped. It's quite handy because in order to implement this in pure Java, you would have to write few iterations and block of code. Instead of writing that block of code, this is quite handy to do it like this. Okay, basically, at the last slide. So what to say here? So Lambda expressions are much more concise than various and animals class. But of course, in order to use them, you have to get acquainted with the functional interface notation to create your own or use some of them. So are the streams. Streams are very easy. Out of the box parallelization, which is very, very handy. Lots of operations that allow you to do manipulations on the collections. And this grouping feature, which I showed you, the last thing, is a killing feature because it saves quite a lot of code writing. This is my record, I think. And now let me show you a few examples. I think these examples you can look up later on as well on your own. So basically, here, the first example, we have a array of integers. So with some simple examples of streams, we can basically sum them up, right? Kicking a stream, and this is a stream, and we basically sum it up. And here we just map from this value into the squared value and sum them up. Distinct and sorted. So we make the distinct list, distinct stream, then we sort, then we print it out. Here's the range from 1 to 10, right? So this is another operation which I did not describe. This is the range from 1 to 10 for the integer stream. Distinct sorted elements 5 to 7 in string. So these are some kind of the operations as well accumulated. Counting differently, so basically mapping to 1, reduce and reducing, reduction starting from 0 and then plus plus. Right, so this is the thing which we can run right now and take a look into the output. So that's basically it, right? 114, this is times 2, distinct and sorted, obviously, range from 1 to 10, exclusive 10, as usual in histograms and bins, distinct sorted and in string, right? So count 18, count differently 18. Okay, so these are the examples, simple examples. This is the example which displays how it's easy to do a parallel operation. So basically we have a list of persons, and this list of persons gets generated, I think. There are a bunch of persons actually, and we have the lookup for the number of cores on the machine. Then we check time. Then we have a person stream, and we limit to 8. So basically we pass the stream of persons. As you can see here, streams of persons are being passed to this function. And in this function, for each person in the stream right there, it basically sleeps for 1 second, right? It sleeps for 1 second, right? This function is being called. Okay, so basically 8 sleeps, 8 sleeps, and 8 sleeps. And this stream is the default one. This stream is the sequential. This is the call for the sequential. So we want it explicitly to be run sequentially. And this stream is parallel. This is how we pass it to the function. This is debugging. No, okay, whatever. Debug should work as well. So let's take a look. So core is number 4 in my machine. As you can see, we have 4 cores. It should be running. Okay, so default elapsed 8 seconds, right? So it slept for 8 seconds. Each person sleeping 8 seconds. So this was a sequential sleep, 8 seconds, right? And parallel, basically 2 seconds elapsed. because this is a parallel execution on 4 cores, so 4 times faster, as you can see, right? And it's very easy to do that. So basically you start with parallel stream and it becomes much faster in the case of the presence of the multiple cores. Okay, so this is another example with mapping and filtering. So this is an example of basically this is the ages, these are the ages, and from the list of persons we find these persons and print them out. And these are the names. We find persons that match the name, equal n, yeah, that match the name. You can imagine that this list of persons is huge and it's random generated. So we want the first persons that have this age, right, to be returned, to be printed out, and we want the first persons that match these names to be returned. Okay. So this is kind of a mapping, right, operation. So a run file. Let's take a look, the output. Okay, so elements were 1 million. Yeah, this is 1 million elements in a list. So basically it found the first ones that match 12, 23, 33, 43, and 53 age. And it found the first persons that are actually of the certain name, A, B, C, D, and so on. Yeah, random generated persons. Okay, so, and this is an example of some more elaborated example, I think. This is, again, we have a list of persons and we kick up the stream. Persons by age. Looking for persons by age A, found PP. Okay, just tells that it found some person, right? So person by age. This is a function, right? This is one function. This is another function. This is a predicate, right? Function and predicate. So we combine them into the stream. Okay, let's take a look what will happen here. The combination of two things. But so as you can see, we can use these predicates and functions. So basically lambdas as a variable, we can move them around quite easily, since this is a functional interface. So yeah, looking for a person by age 12, found person, yep, and just printed it out, right? Looking for person by age 23, found one, and so on and so forth. Looking person. Okay, so these are various lookup examples that you can explore a little bit more. Okay, so this is again an example which basically does some accumulation and combination, right? So basically what we have right here, again, we have a list of persons, and this is our initial stream. We start as a parallel stream, and when we filter, that the person would be more than 18 years old and less than 22. Okay, sorry. So this is something like the first level students. We are limited to 100 when we take them distant. So they are being only unique ones, and we collect them into the course, right? So we put these guys into single course. So how we do that? We do this initially by supplier. So the supplier is just supplier of course, as you can see. This is a constructor of a course. Then accumulator, this is where we accumulate these students. So see, the course gets students add. So we are adding students to the course. As you can see, our course has a collection of students. So we are adding them, right? And at the end, we have a combiner. Because we are running in multiple threads, this is a parallel stream, so we need to combine few courses, because each course will be created on each thread, right, on different thread. Then we will accumulate, and here we will combine these courses into one. So this is B consumer. We have 1, course, another course, right? So basically we take all the students from one course and put into the first one. Okay, so this makes it possible, this collector, it makes it possible to run this accumulation, this collection basically on multiple processes. As you can see, we have a course created very many times, right? But at the end, we have just a single course returned with a bunch of students pre-selected by our conditions, right? So this is 100 of students accumulated. Okay, so basically this kind of a collection allows you to be split into multiple threads, and so operation becomes much faster. Okay, so these are the examples. You can find them out on the GitHub. I think this is not listed over here, but it's quite easy because you go into the GitHub and you just basically go into project, organization, and over here there is a streams and lambdas as well examples. So you can look up these examples. Okay, so basically that's it for today. This I wanted to say. I'm stopping the recording.